Hello, my name is Wong, and I have a bachelor degree in mathematics and statistics from University of California, Davis. Currently, I am enhancing my skill as a data analyst through a data analyst and Python bootcamp at Savvy Coders. As an analytical thinker, I enjoy exploring new programming language and tools that help me extract insight from data and build actionable solutions. In this Capstone project, we will be diving into the San Francisco Bike-Share system data, which is available on kaggle.com. By utilizing a combination of Excel, SQL, Python, and Tableau techniques, we aim to analyze the usage pattern and trends over time. Our primary objective is to identify who is using the system, how it has been used, and how the factor that impact bike rental behavior. Ultimately, we hope to provide actionable insight to bike share operators, city officials, or other stakeholders to help them optimize their system performance and improve the overall user experience. So two major focus. What is the rental trend over the time, like over the year, months, weeks, and days? And also, what is the weather factor that impact on the rental bike count? So we have 4 sets of data. And in the beginning, I was first try to run all 4 sets of data in Excel, SQL, and Python. However, this is the first obstacle that I have. One of the data set is actually having data size over 2 GB. So I am not able to open it up in Excel, SQL, and Python. The only way, well, I can only use Tableau, and only Tableau can show me something out of it. So this is the graph that I got from Tableau. Two major things that we notice in here. First, when we look at the month perspective versus by percentage, we can see a big chop off from March to July. So we are not able to determine how is the by percentage been used over this couple months. So we can only assume the month August to September have the highest number of bike count over the year. Second thing that we notice here, we only see 1, 2, 3, 4, 5, 5 station ID. So which means in the data set, it have more than 30 stations. But here it only shows the first 5. So all 4 tools that we have, Excel, SQL, Python, and Tableau, wasn't able to open this data set. Even though Tableau can open the tip of the iceberg. However, we need to do something to let the entire data set run in the system. So I write a function in Python to reduce the memory usage. So this is basically I write out a for loop which modify and found the smallest data type of each column in the data frame. And I also found the maximum and the minimum when it detects the data type is not an object. And then I found the smallest data type and put that smallest data type value into the column and exit out the loop. So it come back the result. The original data set is over 2 GB. Right now it downsized to a little bit over 700 MB. So right now, I'm able to open this data set in all four tunes that we have. So going back to open this data set in Excel, the Excel shows four column originally, which is the station ID, byte available, DAC available, and also the time. I first play with it in Excel, change change a couple of things, change the format change the time format from the time itself into like stuff that we need in different columns, and also do some calculation for the occupancy percentage of all the byte count. And right now I have the data set ready, so I'm ready to put it in SQL or Python. So let's do Python. Because one of our focus is the trend over time. So I have the time format change it to into weekdays. So right now I can put the DAC amount over the weekdays. So small finding that I have now is for all the Wednesday to Friday and also Sunday, it has the highest byte count. Okay, continue. Here is our second data set. Um, name is the name is chip. Is most likely the duration. Um, Slightly large data set. So beside Excel, I also open it in SQL. Play around with SQL. Since the data set is having like all the duration for each trip with the starting date, starting station name, starting time, and also end date, end time, and end station name. So I was first trying to look at what is the longest duration for all the trip in here. Running some SQL command, come back, the result, it actually, in the very beginning, I thought this is a glitch because the time is actually from December 6, 2014 to June 24, 2015, which is over half a year. So I kind of think this might be a glitch. So I found the first 10 longest trip to compare to the longest one I had. And actually, many of them is over a week or two. So I can tell the data set is still normal. And I also found how many trips that actually longer than 1 day. And it actually has like close to 300 trips. It's longer than 1 day. And since the dataset also show the subscription type, so I try to see if the unsubscriber, which is the random customer, actually have longer duration than all the subscriber. And plotting a pie chart using Python, the result come back. Yes, the random customer have much higher trip duration in general than the subscriber. Kind of makes sense. Like the customer, the random customer, they might not aware that over 30 limit of by writing the price change. And also, since it's in San Francisco area like that, it might have like a lot of them is like tourist, so they may not know the information behind the bike. Also in Python, try to look at what is the most popular duration. First, see in 99 percentile, 0 to 50 minutes seems like the longest. Want to zoom in a little bit closer. So in 95 percentile, we can see that for 5 to 10 minutes is the most popular trip duration. And looking back on our focus again, so the random time over time, this time we have it down to hour of day, and I have the weekdays and all the weekend days. So on working days, Monday to Friday, we see that the bike count is slightly increased after 7 a.m. and keeping it up all the way until it falls after 5 p.m. So it kind of makes sense. People go to work and come back from work on the weekdays. So here's our little finding. From 7 a.m. to 5 p.m., we actually have the highest amount of bike during the day. So we have the first two data set mostly work in Excel, SQL, and Python. For the rest of the two data set, we're going to use more Python. For station, so this data set, I noticed one thing different. It have a latitude and longitude column, what the other three data set doesn't have. So I first go into Python, and I know that Python have a library called Folium, which can pop some beautiful graph and some heat map. So plotting all the station location, the red indicate how crowded it is in the city, and also represent the number of bike count. So I zoom in a little bit to see how many stations actually it is on the map. So this is for San Francisco, this is for San Jose. And also the red represent the highest number of bike count, and we can see there's a lot of stations in San Francisco. So I put the number of stations per city and also the number of bike count per city, and result come back matching. San Francisco have the highest number of station and also the highest number of dot count. Okay, for our last data set, we have the weather data set, contains the time, day, and all the different number for the weather factors. Uh, put that on table. Since table are able to show me all the different weather factor and how are they related to the bike count. So here's the finding that I have. For all the weather factor, we have the temperature from 60 to 70 Fahrenheit and the wind speed from 15 to 20 miles per hour, and for the humidity, less than 90%. All three have the strongest relationship to the bike capacity. And also for the weather event, we have foggy day, foggy and raining day, normal day, raining and thunderstorm days. And very obviously, we can see that we have the highest number of bike during the normal days. And finding we have for the weather impact, yes, the temperature, wind speed, and the humidity have the strongest relationship, and also the normal day have the highest number of bike count. So after all four data set, we have our founding and conclusion here. Um, Weather factor play a important impact on the bike rental. Um, the most appropriate range for temperature is 60 to 70 Fahrenheit. Um, Most users tend to use bike from Wednesday to Friday and Sunday. Um, the rental bike months highest is on August to September, and on weekday 7 to 5, weekend day 9 to 5 are the most user hours. So here it concludes our presentation. All right, thank you everyone, and this is my presentation.